Okay, first we will go for the question number 47. It is based on the Lensmaker's formula. First we start from Lensmaker's formula and then we'll go for the combination.
Okay.
One more.
Okay.
Okay, first we'll first collect the data given. Okay, convex lens of refractive index. They have given refractive index of the convex lens. Focal length, it is also given in R. Focal length in R. Calculate the change in focal length when it is immersed in water of refractive index 4/3. See, this case I have discussed in the last class itself. Okay, we know for convex lens, the base formula 1 by f equals to n2 minus n1 divided by n1, 1 by r1 minus 1 by r2. Okay, for r,
N minus
n1 equals to 1. Okay,
N minus
air filled region n2 equals to here it is 1.5. 1.5, they have given fr equals to 18 centimeter. 18 centimeter. Now the entire setup is immersed in water. Water with refractive index 4 by 3. 4 by 3. Therefore, 1 by f water becomes n of, here it is glass. Okay, glass minus water divided by n water. Again 1 by r1 minus 1 by r2. Here the term inside the bracket now, the radius of curvature is same.
yes, sir.
Radius of curvature is same. Okay. Now you insert the values. Insert the values. We are going to solve the equation for 1 by fw. Okay. 1 by fw is, that is what we are going to find. Calculate the change in focal length. Okay. How much, what will be the value of the final focal length in the system? So glass, it is again 1.5 only. Okay. And for water, 4 by 3 they have mentioned. So 4 by 3. Here 1 by R1 minus 1 by R2.
R2.
So you just take it as equation 2 and insert everything here. 1 by FR is equal to n, it is 1.5 minus 1 divided by 1, 1 by R1 minus 1 by R2. Therefore, this entire term 1 by R1, 1 by R2, 1 by FR, it is 18, right? 1 by 18. 1 by 18,
Yes.
this one becomes 0.5. 0.5. Therefore, 1 by R1 minus 1 by R2 becomes 1 by 18 multiplied by 0.5. Is it okay?
Yes, sir. 1 by 36.
Yes, yes. Now insert the value in this equation. You no need to divide the values, you just insert 1 by fw equals to, you just now have multiplication. Multiplication 3 1.5s are 4.5. 4.5 minus 4 and the 3 get cancelled in the denominator. Therefore, you will only get 4 here in the denominator. So
Yes,
okay.
sir.
Now
Yes,
it
sir.
is 18 into 0.5. So here it is 0.5. So 0.5, 0.5 get cancelled. Therefore, FW equals to 4 times 18 centimeter. Again, it is 4 times Fn values 72 centimeter, right?
Yes, sir.
72 centimeter. So this is based on what is that? Refractive
Lens width.
index, the relation between focal length based problem. This one. Now you see the radius of curvature, question number 46. Again, this is also based on same formula. The radius of curvature of faces of double convex lens, 10 centimeter and 15 centimeter. Okay. If the focal length of the lens is 12 centimeter, find the refractive index of the material of the lens. So it is again based on the same formula. Same formula. Just
Sir, in this R1, R2 are given, right?
yes, yes, everything is given. Okay. Focal length it is 1 by 12. 1 by 12. N2 refractive index, that is what we are going to find. Okay, refractive index we are going to find. And if here nothing is mentioned about the medium, it is where it is kept. So if nothing is given, it is air. Okay, so nothing is given,
Yes.
so therefore it is air. And about the radius of curvature. Okay, radius of curvature, we always take R as positive, R1 as positive. Okay, first is R1. So again, here also the usual convention. First one is R1, second one is R2. Okay, first phase R1 and R2. Suppose if you have doubt, so this is a convex lens. So this side, no, this side, it is R1. Center is R1. And expanding the sphere, spherical surface, the back side is R2. So R2 is negative, R1 is positive.
Okay, sir.
Okay. Therefore, this is 1 by 10 minus 1 by minus 15. Okay, R2 is negative. So don't get confused. Okay, one of the faces is positive and the another side is negative. So usually you go for this convention. Okay, right side is positive, left side is negative. Okay, now we solve the values 1 by 12 equals to n minus 1. Here it is positive, so they become positive. Now 15 plus 10 divided by 15 into 10. We go for the three table. 4 threes and 5 again 2, it is 5. So 25 divided by 2 into, here it is 25. N minus 1. So 25, 25 get cancelled. So n equal to 1 plus 1 by 2. That's 3 by
2.
3 by 2. Therefore, n is equal to 1.5. No unit. Because refractive index, no unit. Is it right?
Yes,
So this
sir.
is a direct question. Simple question. Next, This question number 45, actually, it is NCERT. They are not coming under combination.
If chemical contact. Sir, the answer for the 44th will be 1 by F1 plus 1 by F2, right?
Yeah, 40.
4.
Yeah, that one we discussed. It is a that question.
Yes, sir.
I said 45.
4.
Yes.
Which one?
It
Which
is
one?
NCERT question. Okay, NCERT exercise question. That we will discuss. Okay, actually, we'll copy the question. Question number 45. The beam of light converges at point P. A concave lens of focal length 16 cm is placed in the path of this beam 12 cm from P. Draw a ray diagram and find the location of the point at which the beam would converge. Okay, question. For this case, they asked us to draw the diagram also. Now consider we have a principal axis. Along that principal axis, we have a point P. Point P.
Yes, sir.
See, the beam of light, it is converging at point P. And actually, it means that we are getting a ray which is converging at point P.
Yes, sir.
Is it right? But for our simplification, we'll go for only one ray. Okay, only one ray it is. Therefore, actually, at this particular point, it is converging. And the second step is, and now we are going to place a concave lens of focal length 16 centimeter. Okay, concave lens of focal length 16 centimeter. What is that? In front of this point P. Okay, before 16 centimeter from the 12 centimeter. 12 centimeter distance, we are placing a concave lens. Now what happens now? By placing the concave lens 12 centimeter in front of 12 centimeter. Now what happens now? This becomes the object distance for this particular point P. Now what happens now? Before inserting the concave lens, what happens? The ray is converging at point P. Now we are inserting the concave lens at a distance 12 centimeter from this point. What happens now? Here, this point P acts as a virtual object for this concave lens. Now we are
Okay,
going, we are what is it? Assuming like this. Okay, the point P as virtual object. Therefore, the focal length it is given as 16 centimeter, but it is negative. But object distance it is positive. Why? Because it is in the right side of the ray, or it is along the ray. It is right side of the side concave lens. Now I'll go for the lens formula. 1 by f equals to 1 by v minus 1 by u. Now
U.
insert the values. It is minus 1 by 16 equals to 1 by V minus 1 by 12 centimeter. Now you solve the equation for 1 by V. 1 by V equals to this 1 by 12 minus 1 by 12 becomes plus 1 by 12. So plus 1 by 12 minus 1 by 16.
16.
Now have the calculation. 16 minus 12, it is 4. 4 divided by 12 into 16. 12 into 16. So get cancelled. 4. Therefore, V becomes 48. Is it right? 48 centimeter.
Yes, sir.
48 centimeter from the lens. Okay, 48 centimeter from the lens. So V equals to 48 centimeter. From the P, it is 12. So just remove 12. It is 36 centimeter from point P. Therefore, the final image, no, it is converging at this point P.
Yes, sir.
Final, suppose our final image, it is located at this point. So it is a final image. Therefore, the actual ray, it is converging at this point. So instead of converging at point P, it is converging at this point. Okay. And
Yes,
you draw the exact diagram. The exact diagram in the bottom side also. But you draw properly. Okay, you draw equally. It must be symmetrical. Okay, but I have some problem in drawing this. With the tab, no, you just while drawing the diagram, you just have a symmetry.
Yes, sir.
So this distance is B from the focus from the lens. It is 48 centimeter. Okay, in the textbook, they have given two scenarios. Okay, one is concave lens. Okay, concave lens. But in textbook, they have given two situations. Another situation is convex lens. See, instead of concave lens, no, they used convex lens with a focal length of the same value. Focal length, sorry, 20 centimeter. Okay, again, we have to apply the same. See, before finding the value, we don't know where it is exactly converging. We don't know exactly.
Yes, sir.
Okay, first to find the value and complete the diagram. That's all. Okay, so next we'll go for another one. This one 43 and all, it is very simple. Okay, convex lens of focal length 25 centimeter is placed coaxially in contact with the concave lens of focal length 20 centimeter. Determine the power of the combination. So it is simple. So 1 by F effective equal to 1 by F1 plus
1
1 by
plus 1.
F2. Okay, but the thing is, it is given in centimeter. Okay, for that, you have to be very careful. You have to convert the centimeter into meter.
Meter. So it will be, sir,
Otherwise,
1
you
by.
find you find the combined effective focal length and then you reciprocate it.
Okay, sir.
Okay, instead of calculating the individual power, no. So sometimes it makes you get little bit confusion. So we'll go for that question also. So usually, sometimes students they commit mistake. It is easy to find the effective focal length. So instead of P1 plus P2, 1 by F effective equals to 1 by F1 plus 1 by F2. So the value 1 by 25 plus 1 by 20. Both are same. convex lens.
So one is
Sorry,
concave, sir.
concave lens. Therefore, one is minus.
Minus.
Okay, it is minus. Minus. So minus 20 plus 25 divided by negative of 20 plus 20 into 25. It is 5. um, 5 divided by 25 into 20. 500. Okay, it is minus 1 by 100 centimeter. Okay, then F effective for 200
Minus.
minus 100 centimeter. Then
Minus
power
one.
is, yeah, power equals to, yeah, it is 1 centimeter, 1 meter minus 1 meter. So 1 by 1 by F effective equal to minus 1 diopter. Minus 1 diopter. Okay. So these are all simple questions, but sometimes they'll make some confusions. Now you see this question, but
So,
it
sir,
is
I'm
simple
joining.
only.
Sir, I'm joining in another device. Can you let me in?
Yeah. Now next question is the double convex lens. See, this is also similar to what we discussed so far. See, instead of giving focal length, no, they have given power,
Yes, sir.
but remaining things are same. So it is made of glass 1.1, 1.55, but we need to find the value of radius of curvature. So this question it becomes, so 1 by F equal to n minus 1. Instead here no liquid is placed. It is 2 by R here. 2 by R because they are equal radius of curvature.
Yes, sir.
Okay, therefore the formula it becomes this value and directly you make it as power. That's all. P equals to, you just have 5 plus 5. That's all. Plus 5 and the refractive index, everything is given. So you just solve the problem. It is very simple only.
Yes, sir.
I'll go for combination. This one. Question number 48. Again, so whatever it may be, in case of combination, what happens? The object, so the image of the first okay, the image produced by the first lens serve as object for the second lens. Okay,
In the following.
okay. Read the question. In the following diagram, object O is placed 15 centimeter in front of convex lens L1 of focal length 20 centimeter. Okay, here it is the position. 15 centimeter object was placed in this point.
And the final image from that. Sir, we need to find image distance. Sir.
Yeah. First, Object is placed 15 centimeter in front of L1 focal length. Yeah, focal length for this case is 15 centimeter, and so 20 centimeter, 20 centimeter,
1/20.
and second focal length. So we need to find F2. Okay, F2, and the data given is the final image is formed at I at a distance 80 centimeter from L2. Here, yeah, it is 80 centimeter, and final image is focal length 20 centimeter, and the final image formed at I at distance 80 centimeter from second lens.
Sir, then we need to find the virtual object, right, sir?
Yeah, virtual object. And one more thing, they have in the diagram they have mentioned that 20 centimeter between the two lenses.
Okay, sir.
Yes. Yeah. That is not actually given in the actual diagram. Okay, that is not actually given because they might have written after solving this answer.
Okay, sir.
Okay, now we'll come to the point. Okay, first 1 by f1, 1 by f1 equal to 1 by u 1 by v1. This has the virtual object is as v1 u1. So this is u1 equal to minus 15 centimeter. Okay, u1 minus 15 centimeter. Now focal length it is positive. Focal length it is 20 centimeter. So 1 by 20 equals to 1 by v1 minus u1 is negative. Therefore it becomes positive. So 15 centimeter. Therefore 1 by v1 1 by 20 minus 1 by 15. Okay. Why we will see one by one. Okay. Minus 15 plus 20 divided by 15 into 20. It is 15 into 20. So we are going to get negative answer. Minus 5 divided by 15 into 20. So 3 becomes minus 1 by 60. Okay. V1. Actually, V1 equals to minus 60.
Yes, sir.
Minus 60. Now what happens now? Actually our final image, it is located somewhere behind the lens one. Behind the lens one.
Oh, so like,
Yeah. He is in the backside of the lens L2. Also L2 also. Now therefore, this 20. Wait a minute. 20. Now the image is acting as an object for the lens L2. Okay. Now we will directly insert the values given. Okay, so instead of checking the exact diagram, so we come to the conclusion that V is minus 60 centimeter.
yes, sir.
Now we will go for 1 by f2. 1 by f2 equal to it is the image v2. V2 minus 1 by u2. But u2 equals to v1.
Yes, sir.
U2 equals to v1. Now insert the values. Okay, 1 by f2, that is what we are going to find. 1 by f2. Find the focal length f2. But v2,
Yeah.
v2 in
One-
the question itself they have
80.
given the final image is formed at a distance 20 centimeter from the second lens. Sorry, 80 centimeter. So from the second lens it is 80 centimeter. Okay, but
Yes.
here is a trick. Okay, we don't know the exact value of v2. So exact
Oh,
value of v2 we don't know exactly. So u2 alone we know.
yes, sir.
So v2 u2 it is 1 by minus 60. But what about V2? V2 it is okay 80 centimeter. Yeah. Then it is that is V2 only.
Sir, 1/80 plus.
Yes.
I see.
So 80 only. So 1 by 80. So solving the values. Solving this negative get cancelled. Okay, negative get cancelled. 1 by 80 plus 1 by 60.
60.
So taking 140, right? 140 divided by 80 into 60. 0 can cancel. Then 2 sevens are 3.
6, 7.
Wait for that. I think there is a mistake. There was a little bit confusion.
7.
So actually, they have given answer is 40. We'll again go check it once again. Final image form that I insert. Is 1 by 80. Yeah. Actually, we made a mistake, small mistake here. I'll come to that. The mistake is actually the lens L1. The lens
Yes.
L1, the image is formed 60 minus 60 centimeter.
Yes, sir.
Is that right? But we don't
Yes, sir.
know the distance between these two lenses.
Yes, sir.
Okay. And in the image they have given 20 centimeter. Actually, I think we have to take this distance between the two lenses 20 centimeter. Okay, actually it is not mentioned in the paragraph. I had some confusions. Okay, so this 20 centimeter must be also included. So
Okay, sir.
therefore the effective object distance, the total object distance from the lens L2
Minus 40.
is 60. So actually this is also minus 20. So minus 20.
Oh, minus
This is
80.
also negative. Therefore it is minus 80 centimeter. So this is our U2. Okay, it is
Oh,
not like U2 equal to V1. So this one is wrong. Therefore V2 is 80, 1 by 80 minus 80. Therefore it is 2 divided by 80. 1 by F2. Therefore F2 equals to 40 centimeter. Okay. So I thought they have made a mistake after writing what is it, after the solution, I thought. But this actually question, I think. 20, the distance between the two lenses, it is 20 centimeter. But it is not
oh.
mentioned in the paragraph.
Yes, sir.
Okay. I'll go for another one problem. 49. 49, the diagram is not given. We will see one by one. This question is combination of lens and mirror.
Oh, okay.
Convex lens. Convex lens of focal length 20 centimeters placed coaxially with a convex mirror of radius of curvature 20 centimeter. The two are kept 15 centimeter from each other. The point object lies 60 centimeter in front of convex lens. Draw a ray diagram to show the formation of the image by the combination. Determine nature and position of the image formed. Okay, now we will solve one by one. So we have to draw the diagram. So first we draw based on the given data. So we have a convex lens
Yes, sir.
and we have a convex mirror. Okay, and focal length of convex lens, we take it as f1 20, and radius convex mirror radius of curvature It is 20 centimeter. It is a curvature 20 centimeter. Kept 15 centimeter each other. Okay, point object lies 60 centimeter in front of the convex lens. Okay, and the point object. So we have an object, point object. Point object is like it doesn't have any height. Okay, and the distance between point object and the lens is 60 centimeter. So we take it as minus 60.
U.
Minus 60. Yeah. U. Draw the ray diagram to show the formation of the image. Okay, what happens now? First, initially, the convex lens forms an image somewhere. Okay, somewhere. We don't know exactly whether it is in front of the mirror or it is behind the mirror. Okay, after calculation, we will come to the conclusion.
Yes, sir.
Okay, first step, 1 by f1 equals to 1 by v1 minus 1 by u1. We take it as vu1. Okay, so 1 by v1 equals to 1 by f1 plus 1 by u1. Insert the values 1 by 20 minus 1 by 60. So 60 minus 20, it is 40. So 20 into 60.
So 1 by 30.
40. Entirely 30. So V1 is 30 centimeter. So actually, where it is exactly located?
It's front. In front of
It
the.
is 20, 30 is back side. So exactly the back side. So 30 centimeter. So our I dash. Okay, I dash. The first object. See this distance now?
Is 10.
Yeah, it is actually 30. No, 15 centimeter only. Because already the distance between the convex lens and concave convex mirror is 15. So
Yes,
our
sir.
object distance is, so V1 is located plus 30 centimeter. No, therefore
Yes, sir.
from the mirror it is 15 centimeter only. So
Yes, sir.
therefore this serves a virtual object. Okay,
Yes, sir.
this is, we call it as U2. Okay, U2. So U2 is 15 centimeter, not V1. Because we are, calculating from this particular mirror. Therefore,
Yes.
1 by F2 equals to 1 by V2 minus 1 by U2. Here, F2 is negative. Here, R is given. Therefore, F is equal to F2 is 10 centimeter. Minus 10 centimeter. So, minus 1 by 10 equals to V2. That is what we are going to find.
Sir, it will be plus red, sir, in mirror formula.
Mirror. Wait a minute. It is a diverging mirror, right? Diverging mirror. Yeah, I'll come. Yes, it's positive. It is positive. So 1 by 10 equals to V2. V2 is, that is what we are going to find. V2 minus U2 is, again, it is positive value only. It is plus 15 only. So 1 by 15.
50.
So 1 by V2 is 10 plus 1 by 15. So it is 25 divided by 10 into 15. So 3, 5, so 1 by 6, right? Otherwise, I made mistake. I made mistake. No, 25 divided by 150. Yeah, 25 divided by 150. They have given me as 30. Textbook they made this mistake. It is 6 only, right?
Yes, sir.
Mm,
Like 10.
I
3 plus.
think they,
I like 15. So 1 by 6.
yeah, 1 by 6, but in the solution it is given as 30. And see.
Sir, they are not asked the, I think, the focal length of the second one.
Determine the position of the image they asked. Nature and position. Um, the question is in SL Aurora, but we'll check the answer. Mm, centimeter. Mm, use positive. Sorry. Actually, it is positive, right? We have taken lens formula. We made a mistake. Here it is mirror. Here only it is lens. So this mistake. So lens mirror instead of mirror formula, we have taken lens formula. Okay, therefore 1 by V2 is equal to 1 by F2 minus 1 by U2.
Yes, sir,
Therefore
30.
1 by 10 minus 1
1 by
by
15.
1 by
15.
30, right? 15.
1 by 15, sir.
Yeah, 1 by 15.
Answer is 30.
Now it will come like 30 centimeter. Okay, 30 centimeter is from this mirror. From the
Yes, sir.
mirror, it is 30 centimeter. Okay, therefore it is greater than this distance. Okay, and then extend this line. Extend this line. And have our final image. Final image. So it is converging at this point.
Yes, sir.
This is our final image. So this is the exact diagram. And nature of the image, the final image. So in order to get the nature of the image, what we have to do? No, we have to go for the magnification. Magnification. Okay, what will be the magnification of the space? So they have mentioned it is final image is virtual image.
Sir, 30 by 15.
Because virtual. It is a virtual image. Why? Because the image is formed behind the mirror. Formed
Behind that.
behind the convex. So when it is in front of the mirror only, it is real image. So behind the mirror, it is virtual. Okay, that is enough, I think. Okay. The sizes it is not required. The size it is not given in the solution. Okay.